Our solar system is a vast and mysterious place. It's full of wonders. One such wonder lies beyond the giant planets. This region is called the Kuiper Belt. Imagine a giant donut in space. This donut is filled with icy objects of all shapes and sizes. This is the Kuiper Belt. It starts near Neptune's orbit, about 30 times farther from the Sun than Earth. The Kuiper Belt extends outwards for billions of kilometers. This region is like a cosmic graveyard. It holds remnants from the early solar system. These remnants are like time capsules. They offer clues about how our solar system formed. The Kuiper Belt is a fascinating place. It's teeming with icy objects and dwarf planets. Exploring this region helps us understand our own cosmic neighborhood. Let's dive in and explore this intriguing region of our solar system. The Kuiper Belt is divided into two main parts. The first part is called the Inner Kuiper Belt. It's the region closest to Neptune. The Inner Kuiper Belt is home to Pluto, the most famous dwarf planet. Pluto's orbit is quite different from the planets. It's tilted and elliptical. Objects in the Inner Kuiper Belt are considered resonant with Neptune. This means their orbits are influenced by Neptune's gravity. They orbit the Sun in a stable and predictable way. These icy worlds are like frozen time capsules. They hold secrets about the early solar system. Studying them can tell us a lot about how our cosmic neighborhood came to be. Beyond the Inner Kuiper Belt lies the Outer Kuiper Belt. This region is much more chaotic and less understood. Objects here have more eccentric orbits. They're not as influenced by Neptune's gravity. Imagine a cosmic dance floor where icy objects whirl and twirl. They often cross paths and interact with each other. This constant motion makes the Outer Kuiper Belt a dynamic and ever-changing place. The Outer Kuiper Belt is home to some of the most distant objects in our solar system. These icy wanderers are difficult to observe from Earth. However, they hold valuable clues about the solar system's formation. Their unusual orbits and compositions can tell us a lot about the early solar system's dynamics. In 2015, a spacecraft named New Horizons made history. It became the first to fly past Pluto. New Horizons sent back stunning images and data. These revealed Pluto to be a complex and diverse world. But New Horizons' journey didn't end there. It continued on into the Kuiper Belt. In 2019, it flew past a small, icy object called Arrokoth. Arrokoth's strange, peanut-like shape surprised scientists. New Horizons observations have challenged our understanding of the Kuiper Belt. It has also hinted at the possibility of a second Kuiper Belt. This hypothetical belt would lie even farther out. It would contain objects with even stranger orbits. New Horizons continues to explore the Kuiper Belt, sending back valuable data that helps us unravel the mysteries of this distant region. Section 5. The Kuiper Belt's birth. A story of leftovers. How did the Kuiper Belt form? Scientists believe it's made up of leftovers from the early solar system. Billions of years ago, our solar system was a swirling disk of gas and dust. The Sun formed in the center. The planets formed from the remaining material. The Kuiper Belt objects are thought to be the remnants of this process. They are the icy leftovers that never coalesced into planets. One theory about the Kuiper Belt's formation is called the Nice model. This model suggests that the giant planets, Jupiter, Saturn, Uranus, and Neptune, migrated outwards early in the solar system's history. This migration would have scattered objects in the outer solar system. Some of these objects ended up in the Kuiper Belt. The Kuiper Belt, therefore, provides a glimpse into the chaotic early days of our solar system. Far beyond the Kuiper Belt lies another mysterious region, the Oort Cloud. Imagine a giant spherical shell surrounding our solar system. This shell is made up of trillions of icy objects. This is the Oort Cloud. It's so far away that we've never directly observed it. However, its existence is inferred from the orbits of long-period comets. These comets have orbits that take them far out into the solar system and back. The Oort Cloud is thought to be the source of these icy wanderers. It's like a cosmic deep freezer. It holds remnants from the earliest days of our solar system. These remnants are preserved in a state of deep freeze. Comets are like cosmic snowballs. They're made up of ice, dust, and rock. When a comet gets close to the sun, its ice begins to vaporize. This creates a glowing tail that can stretch for millions of kilometers. Comets come in two main varieties, short period and long period. Short period comets originate in the Kuiper Belt. Long period comets come from the Oort Cloud. Comets are fascinating objects. They offer a glimpse into the distant reaches of our solar system. They also provide clues about the conditions that existed when our solar system was young. By studying the composition of comets, we can learn about the materials that were present in the early solar system. This helps us understand how our cosmic neighborhood came to be. The Kuiper Belt and the Oort Cloud are like cosmic time capsules. They hold remnants from the early solar system. By studying these objects, we can learn a lot about how our cosmic neighborhood formed and evolved. For example, the composition of Kuiper Belt objects can tell us about the conditions in the protoplanetary disk. The orbits of Oort Cloud objects can tell us about the gravitational interactions that took place in the early solar system. These regions are also important for understanding the history of impacts in our solar system. The craters on the Moon and other planets are evidence of past impacts. Some of these impacts were likely caused by objects from the Kuiper Belt or the Oort Cloud. By studying these regions, we can better understand the risks posed by such impacts in the future. The Kuiper Belt and the Oort Cloud are still largely unexplored. New telescopes and spacecraft missions are being planned to study these regions in more detail. These missions will help us answer some of the biggest questions about our solar system. For example, we still don't know how many objects are in the Oort Cloud. We also don't know exactly how the Oort Cloud formed. Future missions will help us to answer these questions. The exploration of the Kuiper Belt and the Oort Cloud is just beginning. These distant regions hold the key to understanding our solar system's past and future. As we continue to explore, we're sure to make new discoveries that will rewrite our understanding of the cosmos. The journey to the edge of our solar system is a journey of discovery. It's a journey that will continue to inspire and amaze us for generations to come.